Welcome back, everybody. In this video, we're going to be talking about factoring trinomials. So intuitive from that name, a trinomial is a polynomial that has exactly 3 terms. A lot of times with those trinomials, we'll see a pretty standard form that looks like ax squared plus bx plus c. For this first part of the video, I just want to look at trinomials where the leading coefficient is 1. So where that a there is a 1. So they're just going to look like ax squared plus bx plus c. Now it turns out, in this specific case, just where a is 1, in just this case, we actually have a very specific form that we're going to get every time we try and factor it. And it's going to look like x plus some number, I'll let that number be L, and then x plus some other number. I'll let that number for now just be M. So I'm always going to get down to this form. And we're actually going to work backwards. I'm going to multiply it back out to get to that standard form so that we can see what those two numbers should be when I start with a problem in that standard form. So multiplying this out, I'll get an x squared term, I'll have an lx, I'll have an mx, and I'll have an lm term. And again, trying to get it to look like that standard form, I'm going to combine those middle two terms. It's going to leave me with an x squared plus the quantity L plus M times x, and still plus that LM on the outside. So now I've written it like this. We can actually see this L plus M here, that's the same as my B term. That L times M, that's the same as my C term. So what I can look for when I'm given that form x squared plus bx plus c is I can look for two numbers that add together to the coefficient on the x term, and they multiply to the coefficient on the constant term. Remember, that constant term is just the term that doesn't have any variable on it. Okay, so this was mainly some motivation as to why we're going to do what we're going to do. Let's go ahead and look at actually trying to factor one of these. So again, for this first part, still just looking at leading coefficient of 1. So for my example, let's go ahead and look at x squared plus x minus 6. So here my c, the thing I'm trying to multiply to, trying to multiply to negative 6. And then my b, the thing I'm trying to add to. Remember, when there's not a number in front of x, we implicitly know that there should be a 1 there. I just have one copy of x. So I'm looking for something that adds to 1. Now when I attack these problems, I always look at the things that multiply to that last term, right? Because I could add all sorts of different things to get to 1. I could do 5 and negative 4. I could do 121 and negative 120, right? I could add any two numbers together and get to that 1. There's so many different options. There's only a few things that'll multiply to that negative 6. So a lot of times off to the side, I'll create a little table for myself just to keep my thoughts organized. And I'll say, okay, what are all of my pairs of things that multiply to 6? So I could do 1 times negative 6 is an option. Negative 1 times positive 6 is also an option, right? That negative could be on either of the numbers. I could also do 2 times negative 3. And I could do negative 2 times positive 3. Those are all my options to multiply to that negative 6. So from here, I want to see, well, what do those two numbers add to? So with that 1 and negative 6, right, 1 minus 6, that'll be negative 5, so that's no good. Negative 1 plus 6, that'll be a positive 5, also not working for me. 2 minus 3, that'll be negative 1, so I'm almost there, but I want that positive 1. Well, it just so happens that this last pair, this negative 2 plus 3, that'll give me that positive 1 that I'm looking for. So if we think back to that last page, right, whatever adds to the coefficient on x and multiplies to that last term there are just the two numbers that are going to be in my parentheses that I see at the top there. So now with my negative 2 and my positive 3, I can factor this into x minus 2 times x plus 3. Okay, so that pretty much does it for those trinomials with the leading coefficient of 1. But unfortunately for us, not all trinomials have a leading coefficient 1. So when we approach something where the leading coefficient isn't 1, we're going to use something that we call the AC method. So if you'll remember back from that standard form we talked about at the very beginning of the video, that ax squared plus bx plus c. The reason we call this method the AC method is because we're going to look at the product of a and c. So the big motivation here, kind of higher level to what we're going to do with this, is that we want to take a trinomial and we want to turn it into a polynomial with 4 terms. And then we're going to just factor by grouping. Right? We already learned in a previous video how to do factoring by grouping when we have 4 terms in our polynomial. So all we're going to do is we're going to say, well, instead of dealing with these 3 terms, I'll just find a way to get 4 terms and then use that method that I already know. Okay. So to see how this is going to work, I'm actually going to go back to that previous problem we just finished up with that x squared plus x minus 6. Now, when we got those factors of 6, when we looked at all those numbers that multiplied to -6, we just plugged them straight into that form that we already knew we were going to get. But it turns out there's something else we can do with it in order to finish that factoring process. And it's that we can replace that middle term with terms whose coefficients are those 2 numbers we found, right? They add to 1, so I could replace them here in the middle. So I could instead just say this is x squared minus 2x plus 3x minus 6. Now it feels a little weird to pull it apart like that, but this is kind of the main crux of what we'll do with this AC method. So we're going to replace that middle term with something it's equivalent to. Right? If I simplified this back out, negative 2x plus 3x is just that x. And now that I have 4 terms, I can do factoring by grouping, right? That's something that we should be a little more comfortable with. So I'll group those first 2 terms together. I can pull out an x. I'll be left with an x minus 2. I'll group those second 2 numbers together. I can pull out a 3. And I'll be left with x minus 2 as well. Then I can pull out that x minus 2. And I'll be left with x minus 2 times x plus 3. And I got down to that same exact place. So this is what we're going to be doing when we look at factoring trinomials with a leading coefficient isn't 1. We're going to do something really similar to this process here. Okay. Let's go ahead and look at an example. So my example is going to be 6x squared plus 5x minus 4. Now instead of just looking at things that multiply to -4, I'm going to look at things that multiply to a times c, right, from that AC method. So a times c in this case is going to be that 6 is in my a spot, and that -4 is in my c spot. So I'm looking for things that multiply to a -24. So again, for me, organizationally, I like to just create a table, just see all those pairs together. So again, since we picked a negative number, so I can do 1 and -24, I could do -1 and +24. I could do 2 and -12, I could also do -2 and +12. I could do 3 and -8, I could also do -3 and +8. And I could do 4 and -6, and again, I could also do -4 and +6. While I'm looking at this list, I still just want to find things that add up to that middle term. Because remember, I'm trying to replace that middle term with something it's equivalent to. So I'm trying to get to that +5. And it looks like the only pair in here that I'll add to 5 is that -3 and +8. So just like we did in that last example, I'm going to leave the 6x squared alone. I'm going to replace the 5x with a -3x and a +8x. And then I'll leave that -4 alone. Right, so all I've done is I've replaced that middle term with something it's equal to, because it's going to let me do that factoring by grouping. Okay, so now let's go ahead and take these first 2 terms, group them together. I can pull out a 3x from there, be left with 2x minus 1. In these second 2 terms, I could take out a 4. I'll be left with 2x minus 1 again. And then I can pull out that 2x minus 1, and I'll be left with a 3x plus 4 times a 2x minus 1. Right? So when you're doing that AC method, just remember that this multiplying, finding these pairs that multiply to a number, all it's doing is it's picking specific choices for these middle two terms so that we know it's going to finish factoring. If you wanted to, you could try replacing it with a different factoring pair, and you'll be able to see that it doesn't factor nearly as nicely as it does when we pick these two that add up to that 5. Right? We need this specific combination that adds to 5 multiplies to negative 24. If we replace the 5 with something different, maybe if we replaced it with plus 20x minus 15x, it's not going to give us that really nice factoring where we got that 2x minus 1 and 2x minus 1, that same thing twice.